So I just wanted to start with kind of where I started here at the Jornada. And I think this is, the case for an awful lot of the research we do, where we think it's important, we know we're interested in it, and we hope it's going to be relevant. And in my case, I got 1 year into my project that I was really proud of and had somebody who I respected a lot. In fact, I had used his work as a justification for my NEFA proposal. Tell me that I was wasting my time. He was actually more blunt than this. And that I should move on to other things like he did. And it's interesting because the longer I've kind of been not doing this kind of work anymore, which is basically looking at the impact of soil fauna on soil physical properties, infiltration. And the more time I've spent talking with people like Deb and Brandon and Dawn, who actually work on the vegetation and how the vegetation dynamics work, the more I've come to understand how important that work could have been if I hadn't given up on it quite so quickly. On the other hand, giving up on it quickly gave me the opportunity to do lots of other interesting, fun things, like work with a bunch of nerds. And that's really what we're going to talk about today. But I think I just wanted to reflect, and maybe Chris is going to reflect more later on other things, but it got me in a reflective mode, that everything here, and I get to see this because I go out and spend an awful lot of time, as everybody here knows, interacting with people around the world. And the cool thing is I actually get to talk about what everybody here is doing and talk about its relevance. And the even cooler thing is it's really easy for me to do that. Because the neat thing about the Jornada is that everything is already connected. We may not talk to each other all the time. We may not be aware of the details. I learned a lot today from the presentation. We may not know the details, but because we work as part of a system, we actually have some understanding about how things are connected. And so that allows me, whether I'm talking with somebody from the State Department of Mozambique, who has never been outside the capital city of Mozambique and is far more urban than any of us here, or if I'm talking with a farmer from Namibia, I'm able to talk about the individual elements of our research as well as the whole thing. And that is really, when I reflect back on it, what drove the development of what I'm going to spend the next 10 minutes talking about, which is this global land potential knowledge system. How can we make that happen for everybody globally through the mobile phones that are increasingly ubiquitous? So the specific challenges, and this of course then comes back to the areas that I think and spend a lot of time focusing on, is that soils are incredibly variable. They vary in their potential productivity, their resilience, their ability to recover, and their response to management. The climate change issues that we now have a group here working on are just adding to that variability. And if you put those on top of the land degradation that's already occurred and continuing occurring, it becomes even more complicated. It doesn't matter how good our extension services is, you're never going to have the right person at the right time with the right information when the land manager needs it. We've got to move beyond that, and we have the ability to. We can Google it, right? The problem with Google, of course, is it doesn't tell you what you need for where you are. And so that's basically what we're trying to create. So why? Why do we care? Why are we passionate about this? Why is the people that are involved in this around the world passionate about it? Well, one, obviously, is the Dust Bowl. And I'm either fortunate or unfortunate enough to have walked into dozens of incipient Dust Bowls around the world. We keep doing it again and again and again. And often, in this case, this is Bolivia, we could have known better. The people that created this Dust Bowl were well-meaning philanthropists with dollars to burn on tractors. And they did. And as a result, they brought tractors into a rangeland that cannot support cultivated agriculture sustainably. We learned this lesson in the 30s. Why else? To objectively evaluate management for carbon, climate change, Creo, etc. These are actually Creo cattle in Namibia. Feed future generations, rapidly monitor management impacts, so we can actually allow people, if they're going to adopt a new management system, to figure out whether it's working for them or not. And obviously, as I said, to share management knowledge globally. And I think this is the statement I come back to over and over again. We were in a workshop in northern Namibia a couple of years ago, and this gentleman, for those in the back that can't see, said, we need to see beyond what we see, because that can help you decide what to do next. And it's really hard to see beyond what we can see, but a lot of the research here at the Jornada is specifically designed to do exactly that. And in fact, the whole LTR network is to look beyond what we can see right now. Okay, so what is Land PKS? People keep sort of referring to it. It's a suite of modular apps that we're going to develop here as part of our team, but also through the efforts of the programming group, APIs that others will be able to connect their apps to. So for example, I just learned of something NASA had developed, which is an in-field sensor built with a soda bottle and a bunch of cheap electronic components that provides real-time information on rainfall, soil moisture, and temperature, and I think a couple of other things. Basically something that they built out of parts for, I'm guessing, $20, $30 or so. And if we can, the problem is to interpret that, you need the knowledge from the Jornada, space, time, the context, in order to interpret what all those fancy readings that NASA's good at collecting mean. It is led by ARS with support from USAID in partnership with all of these organizations, and the number is increasing. And by partnerships, these really are true partnerships where each member is contributing basically what they're working on. What we're serving is the glue, which again is increasingly a role of the Jornada as we serve as a climate hub, a basically organizing node for the LTAR, and a number of other initiatives. And so we're basically doing the same thing internationally. This is the British NSF. This is a remote sensing group in Namibia. This is a sustainability innovation lab at CU. British Geological Survey. This is a big, huge modeling group in Austria, et cetera. And we're basically recognizing we can't do this alone, and so we're partnering with a number of others. So how's it going to work? And how is it working right now? The phone pulls the GPS location and information that the user collects. So this is kind of a crowdsourcing tool initially, and in fact that's how it's serving right now. The soil description, the phone leads you through the process of describing a soil profile, whether you've never seen a soil profile in your life, never done a soil texture in your life, there are embedded videos on it, and it basically goes through the process so that anybody can generate the information that we then need to be able to figure out what the soil is. And so Joel and a group of NRCS scientists are working on how to then use this information to identify the soil that you're on in the cloud, which then leads us to the ecological site, the state and transition model, and will eventually then allow us to, for the users to provide specific feedback if they don't think that state and transition model actually makes sense or they have some additional information. They can then also collect some additional information on the cover so they can demonstrate why the state and transition model doesn't make sense or does, using a rapid, basically a very simplified version of DEMA. And I hesitate to even compare them because it's super simple. Basically covered by structural groups, height, the size of the gaps in the area, and basically in 20 minutes getting a very simplified snapshot of the photo that you would normally get in a much more rigorous way with DEMA, which I think Herrick has talked about in this group. And then in the future, management yields, we're already working with the folks out at the ranch and with Rick on developing a body condition score. App which will basically allow ranchers and farmers to rapidly document the condition of their livestock and record it on their phones, and then be able to automatically look at trends in time in the condition of their livestock, and then compare that directly to trends in the cover. And also we're developing a biomass app. We'll be working in the future to collaborate with some of the groups working on remote sensing already are actually with some folks that are working on basically forage availability models. And so you'll actually be able to start to get a real-time sense for how your livestock are doing in the landscape. And then ultimately, tying it back to some of the research that we just heard about, begin to make some decisions and connect with other farmers who are already working with Creo and say, hey, I'm working in this landscape, you're working there. It looks like you were getting better gains than I was. What's going on? Right? And so it's as much a hypothesis generator, which then leads you to those next questions. Okay, so it's not doing the research. You can use it for research. This is not doing research. This is actually providing the tools for a collaborative knowledge system. So we identify and predict the soil profile. Like I said, we can also link that to ecological sites. And then with additional data on climate, we can predict potential productivity and deliver the products from the climate hub in the future for both current and predicted future. And so that then gets you into adaptation scenarios, which can also then be delivered, and degradation risk. Working with EASA and also with the folks at NRCS, based with Texas A&M, to actually run the models. So we don't want to get into the business of running models. We actually want to do as little as we need in any of this. We basically want to link. We don't want to duplicate efforts. We want to take advantage of folks that are already doing stuff. Identify management options. There's a group called WOCAT, up here, that has already done a really nice job of cataloging and describing conservation technologies. The state of Illinois actually just came out with a really cool website on best management practices that allows farmers to share knowledge on those practices. Just yesterday, I think that came out. So there are all sorts of things that we'll be connecting with. UNCCD has also developed a knowledge base. World Agroforestry Center has been working on decision analysis and has some really good tools to figure out when you need to collect more information to make a better decision and when you've got enough. And then ultimately everything is stored in the cloud, allowing it then to be accessed by everybody else. Just a few quick screenshots. We're very focused, and Rocio Caballero is one of the folks here who's been doing a great job of making sure that we stay icon-based and limit the amount of text to the extent possible. So here's your line point intercept using a 1 meter stick or 1 yard stick, 5 points on it, you drop it down, and no, you're not necessarily recording to species, you're not recording to species, but you're getting the basic life forms. You can then, in the form, you can list your dominant species on your plot. You get your height using that same stick, your gaps, your slope, there's a clinometer embedded in the app and so forth. You're doing your soil profile, again, using icons. So using the apps now, what I just presented here, and we always have to emphasize this, most of this is under development, but right now there are 2 apps out, Land Info and Land Cover. With Land Info, if you're driving around someplace, you don't know what the climate is, there's a button at the top. You hit the button, and as long as you have internet access, it gives you your climate for that location, as well as your elevation, et cetera. If you actually enter your soil profile, it will give you your plant available water holding capacity for that profile. It's good for rapid site characterization and monitoring, and does provide instant cloud storage. It stores it on the phone until you get back into an area where you have internet access, and then it pushes it up to the cloud. And for a break, lunch, when you're just cruising the internet, go to the landpotential.org site, data portal, and we'll be posting. Michaela Blenneman is a collaborator in geography, who's been spending part of her sabbatical working with us. And it's really cool. So if anybody saw Brandon's, I think he presented on Mongolia one time when I wasn't here. Right, so similar kinds of tools here. Basically, these are points that a study that a Namibian collaborator completed. Here's your textures. You can then overlay your bare ground on top of that. And lo and behold, not surprising to most people in this room, but would have been to an author of a paper that Joel and I have been working on recently. Your high bare ground areas are in areas with sandy soils. This is a semi-arid environment. Your loamier soils are going to have higher grass production, right? And so this is the kind of thing then that can be then used, these kinds of tools, to help people then do a better job of planning their management, right? Right away. In areas where we don't necessarily have really good soil maps. So what's going on right now, status, we're really still very much in the development stage. We have not been pushing this very hard. until we really get some feedback on the phone. So we've got there's actually a lot more plots than this that have been collected, but the ones that are currently available through the database for land info, there are more available with cover. We really, and this is not a joke, if this is going to be sustainable, and we had a nice conversation with the folks from USAID a few weeks ago, if it's going to be sustainable, it has to be used by millions and millions of people, okay? And therefore potentially billions of plots. All right, and so we're currently basically developing a strategy for sustainability that is based on a high level of use. Now, is everybody going to go in and describe an entire soil profile? No. We don't expect that. But in order to create the critical mass that you need to sustain one of these kinds of efforts and to add the kinds of value we're talking about, the kinds of big data issues that Deb is working on right now, require this level of density and engagement. And if we don't make it, there are a lot of other efforts out there that are somewhat parallel in nature, and this will then get rolled into one of those efforts. But this is the goal. This is very much like a startup, and in fact, the more I spend working on it, people often describe it to me back after I've described it as a public sector startup, and that's basically what we're trying to do. And like any startup, there's high risk and potentially high reward. A lot of the tools, though, regardless of whether we make it to the millions and millions, we'll be able to continue to use, and people are already using for research. So just a really quick move through this. Historically, this did not grow out of nothing. It grew out of the Jornada. And obviously a huge number of potential connections in the future as we start to work on our 5-year plan. So thanks.